Hello everyone, welcome to the channel. So in this video I have a very simple problem. This is based on factorials, and as we discussed factorials in another video, the basic properties of factorials, I just wanted to show a very simple problem. I know this example is all over the internet, but anyway, this will give us some practice of the properties we learned. So we'll just list down the properties, but I'll try to solve it with the gamma function. And not the most trivial way. So whenever I use factorial properties, I will remember to write gamma functions. And the video where that's explained, I will link it in the description. So these are kind of the properties which we arrived at. And this is the property I will be using to simplify this expression. So under root n plus 1 factorial minus n plus 1, sorry, n plus 2 factorial minus n plus 1 factorial by n factorial. I can write it as I place n plus 2 here, so n plus 2, n plus 2 minus 1, that will be n plus 2, using this identity for n plus 2 factorial, n plus 2 and n plus 2 minus 1, so that's n plus 1 factorial minus n plus 1 factorial. I have n factorial here, so if I write n plus 1 factorial as the next one, then I might be able to cancel something. So I will write n plus 1 factorial as n plus 1 into n factorial. Same here, n plus 1 into n factorial. And in the denominator you have n factorial. So n factorial cancels from all these terms. So you're kind of left with under root n plus 2, n plus 1, n plus minus n plus 1. So I'm going to take n plus 1 common here. Perfect. You already see where this is going, right? This is just under root n plus 1 into n plus 1. So that's a perfect square. Perfect. The root comes out to be n plus 1. So the value of this is this. So what can we possibly say? We can say this for any integer that's n belongs to just what I had defined in the definition of factorial in the other video, is n can be any integer 0 and onwards. So for any such integer, factorial is defined, and if factorial is defined, then this expression always turns out to be a perfect square because the root gives you n plus 1. So if n is 0, this gives 1, and if n is some other value, the root gives that value plus 1. That's it. Very simple but useful for our practice. So thanks for watching video, and thanks for being with me as always, and thank you so much. Thanks a lot.